In this session, let us focus on a question from CSIR Net June 2024. The question is from Vector Calculus. We are given vorticity of a vector field B. V is equal to curl of B. B is kxyz r cap, where k is a constant. Which one of the following is correct? So we are given B is equal to kxyz r cap. Now the unit vector is in spherical polar coordinates and kxyz has to be written in spherical polar coordinates. In spherical polar coordinates, x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta. So if you put 1, 2 and 3 in equation A, you will get B is equal to k r cube sin square theta cos theta cos phi and sin phi also. R cap. Let us say this is F, then this is equal to F R cap. Now to find the curl of B, we write 1 by h1, h2, h3. This is general definition of curl. This can be used in any coordinate system, whether it be Cartesian or spherical polar coordinates or cylindrical. V is equal to curl of B is equal to 1 by h1, h2, h3 times h1 e1 e1 cap, h2 e2 cap, h3 e3 cap, del by del q1, del by del q2, del by del q3, h1 b1, h2 b2, h3 b3. Now h1, h2, h3, these are equal to 1, 1, 1 in Cartesian. In SPC, in spherical polar coordinates, h1 is equal to 1, h2 is equal to r, h3 is equal to r sin theta. In cylindrical, h1 is equal to 1, h2 is equal to s, and h3 is equal to 1. We use these values h1, h2, h3 to simplify writing of curl, divergence, gradient and Laplacian, etc. in different coordinate systems. Now e1, e2, e3, e1 cap, e2 cap, e3 cap, these are unit vectors. In spherical polar coordinates, e1 is r cap, e2 is theta cap and e3 is phi cap. q1, q2, q3 are coordinates. q1 is r, q2 is theta and q3 is phi in spherical polar coordinates. And b1, b2, b3 are the components of vector B. b1 is component of B along r cap. Therefore b1 is equal to F, because it is the component of B along r cap. Now b2 is equal to b3 is equal to 0, because we do not have components along theta cap and phi cap. Therefore curl of B which is nothing but vorticity. This is equal to 1 by r square sine theta. When you multiply h1, h2, h3, you will get r square sine theta. Then you have h1 e1, h1 is 1, e1 cap is r cap, h2 is r, e2 cap is theta cap, h3 is r sine theta, e3 cap is phi cap, del by del q1, which is del by del r, del by del q2 is del by del theta, del by del q3 is del by del phi. h1 b1 is h1 into f is written here k r cube sine square theta cos phi sin phi, and b2 is 0, therefore h2 b2 is 0 and h3 b3 is also 0. This is equal to 1 by r square sine theta r cap times 0 minus 0 minus r theta cap del by del r of 0 minus del by del phi of f. h1 is 1, therefore only f is here, plus r sin theta phi cap times del by del r of 0 minus del by del theta of f. Therefore from here we can say that component of v along r cap is equal to 0 because this is 0, but component of v along theta cap is not equal to 0 because if you calculate this del f upon del phi, it is non-zero, and also component of v along phi cap direction, this is also non-zero because if you calculate this, it will be non-zero. It is not necessary to calculate this, that's why I am leaving it, but if you want to, you can calculate it and you will find that it is non-zero. Now in the question, in the first option, it is saying that vorticity is a null vector for all finite x, y and z. But here you can see that the component of v along theta cap direction is non-zero and component of v along phi cap direction is non-zero, therefore it is not a null vector. Therefore option 1 is incorrect. Now the fourth option says vorticity is perpendicular to the vector field everywhere. Now we know that if vector A dotted with vector B is equal to 0, then this implies A is perpendicular to B. So let's see if V dot B is equal to 0 or not. If V dot B is equal to 0, then V and B are perpendicular. Vorticity is perpendicular to B. V dot B. This is equal to VR BR plus V theta B theta plus V phi B phi. This is equal to, now we have seen here that VR is equal to 0, but V theta and V phi are non-zeros. Therefore here we have VR is equal to 0, BR is not equal to 0, BR is F plus V theta. V theta we haven't calculated it exactly, it is del F upon del phi minus del F upon del phi is here, and then there is an R theta cap minus R theta cap, and then there is 1 by R square sin theta outside, but it is definitely non-zero. V theta is not equal to 0, but B theta, this is equal to 0. V phi, this is not equal to 0, but B phi, this is equal to 0 because B is defined as F R cap, where F is k r cube sin square theta cos phi sin phi. There is no theta cap or phi cap components for B. Therefore this dot product, it is turning out to be 0. Now dot product turning out to be 0 implies V is perpendicular to B. Therefore option 4 is the correct answer here. Now if we change the x, y or z, it will only change f. It will change f here, but still it will give us 0, because we have still Vr equal to 0, b theta equal to 0 and b phi equal to 0. Changing x, y, z only changes the value of f and it does not matter. Therefore the correct option here is option 4. Now option 2 can never be correct, because a vector can never be parallel and perpendicular at the same time to another vector, right? Therefore option 2 is also not correct. Thank you for watching. See you in another video.